Hi, everyone. My name is Valder Bennett. This is my first year here at CIMO, and I'm going to teach CS440 database. Let me talk about my career first. Um, uh, I'm from Brazil. My whole career was in the Brazilian Navy. Uh, English is not my mother language, so you kind of hear some weird accents sometimes. Um, as I told you, my whole career was in the Navy. So I graduated in the Naval College in 1991, and then I served in many warships. I did my master course in computer science, University of São Paulo. My research area was cryptography. And then I went for a PhD in London, in Royal Holloway, University of London. My research area was also cryptography. Um, I spent 29 years of action service in the Navy, Brazilian Navy, from 1985 up to 2014. I worked as a security, after retiring, I worked as a security analyst in a joint project between the Brazilian Navy and Brazilian Army. It's a software-defined radio project. And then I was nominated head of cryptology in a cryptographic and cybersecurity private company and worked there from 2016 up to 2021. And my teaching experience, I taught in a graduate program in computer network security at University of Stasio for more than 6 years. And I delivered many online and face-to-face courses in the Navy, both for people from the Navy and from people outside the Navy. And also, when I was working in that private company, I also delivered many courses in cryptography related things and cybersecurity related things as well. Uh, it's a pleasure to be here as your professor, and I hope we have such a good experience in this course from now on. This will be our book, Fundamentals of Database Systems from Elsmary and Navat. Actually, I'm gonna cover the whole book on my slides. So if you have the book, great. But if you don't have it, uh, you can follow my slides and you're gonna be good. The learning outcomes of our course, after completing this course, you'll be able to first identify popular database management systems, DBMS, architectures, both relational and non-relational databases. Analyze and design databases using the relational data model and relational algebra. And utilize the capabilities of some program applications that uses a typical desktop or web database environments. So this week, we're going to see some introduction to databases. We're going to cover the following topics. What is a database? What are the key characteristics of a database? We're going to talk about database management systems, DBMS. We're going to use an example based on a university database. We'll see the main actors on the scene and the main workers behind the scene, the main characteristics of a DBMS approach, some advantages of a DBMS approach, a little bit about historical context and evolution of databases and database management systems, and when not to use a DBMS. First of all, what is a database? A database is a collection of data organized in one or more tables which have some relationship with each other. Relationship is the key word. You have many tables, and the tables are related to each other in some sense. We start with an isolated piece of information and in its simplest form. And from a set of various isolated pieces of information, we can organize them to create tables and databases. So we have, for example, here data. We can say, for example, on one online purchase by John. John buys something online, notebook or a book, whatever. And then we can organize multiple purchases in a table for multiple customers. For example, purchases by John, by Amanda, by Peter, by Carol. Then we have table to organize purchases. But if you have many information, you need a database. For example, in this database, we store multiple online purchases by John, by Amanda, by Peter, by Carol, and so forth. We can also store pieces of information about the customers, the address of John, the phone number of John, email of John, Carol, and Peter, and everyone. Many information about the customers. And also information about the products. I mean, the name of the book, or maybe the brand of a TV, and whatever. So you store information about the purchases itself, about the people, the customers, and also about the products. So you can store any information that you want. So formally speaking, what is a database? Databases are collections of tables related to each other. This is important. Related to each other, containing data about people, places, things, whatever. These organized data allow for the understanding of a particular phenomenon within a company, whether it's user preferences on a social network or consumer behavior in a financial transaction app. So this is a database. What is a database composed of? A database is composed of following elements: tables, fields, and records. You got a table. Table is a set of rows and columns. So tables store data within a database. A table is a set of related data, and it's made of rows and columns. So it's a set of rows and columns where rows and columns will be tuples and attributes. So the fields, also called attributes, are the columns. So it's going to represent the characteristics of a data, such as, for example, the product ID, the customer name, quantity sold, price, etc. A field is a column in the table containing specific information about each record, each row in the table. And a row, we got records or tuples. Records, also called tuples or rows, represents each data entry within a table. So this picture here explains better. So we have a table. Table is the set of rows and columns. Then we have fields in columns. For example, the product ID, the product itself, description of the product, and the price. And in each row, you have a sale, for example. So sale number one, you have the product ID one, and the, the, the product is a mobile phone, and the price is $1,500. And then you have the second sale, the product ID maybe number 49, the product is computer, the price is $2,000, and so forth. Then you have collection of data. The data are related to each other. So in each row, we have information that is called attributes in each row, and sorry, tuples in each row. And in each column, you have attributes, the characteristics of that row specifically. The schematic design of a database is shown on this side. We have multiple tables, each with different information about the business and with some types of relationship between them. This type of database is called a relational database, but the information is related to each other. A relational database organizes data into tables that are related to each other through common fields. This structure allows for efficient storage, retrieval, and manipulation of data using a standard language. This language is called SQL, Structured Query Language. You're going to see this in detail in a few slides. So let's see this picture here. We have a table called store, another table called customer, another table called product, and another table called sales. On the store table, you have, for example, the store ID. There's a number that identifies that specific store. We have the store name, and we have, for example, the address of the store. You can have many more information, for example, the phone number and many others. The customer table, you have information about the customer. So we have the customer ID, we have the customer name, you have the age, you can have the address, you can have the phone number, you have the email, and whatever. The product table, you have product ID, you have product name, you have the brand, you have the unit price, and have the unit cost as well, and many information that you decide. And then you can build a sales table that depends on elements from other tables. For example, you have the sales table, you have store ID that comes from the table, the store table. You have customer ID that comes from customer table. You have the product ID that comes from product table. And then you have also sale date and quantity sold. So with this information, you can extract information that you need. With this data, you can extract information that you need. And type of database and database applications. We have, for example, traditional applications and most recent applications. The first part of this book will focus on traditional applications. So traditional applications deals with numeric and textual databases only. But we have more recent applications like multimedia databases, like social media, for example, have geographic information systems that you can, for example, know exactly where a store is, know exactly what a warship is on the ocean. In the ocean, you have, for example, know exactly where a car is in the GPS, using a GPS system, for example. So you have geographic information in real time. You have also biological and genome database, a huge database that biology people use to deal with genome, etc. We have data warehouses, we have mobile databases, we have real-time and active databases. So this recent applications will be covered later in the book. For example, chapters 24, 5, 6, 7, 8, and 9. Let's talk about recent developments. Social network. All of you should have a social network, for example, Facebook, Instagram, Twitter, LinkedIn. So they capture a lot of information about people, about communications among people, posts, tweets, photos, videos, and whatever. So every time you are in a social media, every time you like some photo, every time you comment on some picture, this is stored. For example, you are in your Instagram and then you liked a dog photo. The system will know that you like dogs, and then it's going to start showing you more pictures about dogs. The main goal of them is to keep you connected. So this is the way how they earn money. They win money. So when you stay connected, so they will try to keep you connected as much as possible. So they're gonna, if you, for example, search for some city, for example, you're searching Google, you Google search for Dubai, for example, just for curiosity. And then the system will start showing you air tickets for Dubai and tourism information about Dubai and packages for traveling in Dubai and hotels in Dubai and so forth. So sometimes you don't even search for that. Sometimes you are talking to someone about something. I'd like to go this summer. I'd like to go to Paris. Blah blah blah. In, all of a sudden, your mobile shows you in Instagram or whatever some information about France. Did it happen to you? Yes, it happened to me many times. So social media will collect many information as much as you use it. They will collect data about you, and the main goal of them is to keep you connected, and also to try to offer you products that you might buy. So if you are searching for a computer in Google, then you start receiving advertisements about computers in order to try to attract you to buy them. This is, of course, if social media and also to search engines as well. About more recent developments, have new technologies emerging from the so-called non-database software vendors to manage vast amounts of data generated on the web. We call the big data storage systems that involve large clusters of distributed computers. You're going to see this in chapter 25. And we have not only NoSQL, not only SQL systems. You're going to see this in chapter 24. And a large amount of data now resides on the cloud computing, which means that it is in huge data centers using thousands and thousands of machines. Let's see now some basic definitions. A database is, as I told you before, a collection of related data. What is a data? Data are known facts that can be recorded and have an implicit meaning. What is a mini world? Mini world are part of the real world about which data is stored in a database. For example, student grades and transcripts at universities, and you have your mini world. A DBMS, a database management system, is a software package or system to facilitate the creation and maintenance of a computerized database. And a database system is the database, the DBMS software together with the data itself. So the database system is the software and the data. Sometimes the application are also included. I'm going to show you the main impact of databases and database technology. We can see databases in almost everything. For example, in the business, banking systems, insurance systems, retail, transportation, healthcare, manufacturing, all of them use databases. Banking store bank accounts for customers, information about customers, information about money and everything. Insurance stores information about customer, about the product, for example, cars or houses and health and whatever. Transportation, means of transportation, and routes and so forth. Healthcare, information about your health and medical plans and so forth. Manufacturing, about something that is manufactured. And we have service industries like financial, real estate, legal, e-commerce, small businesses. Education, Canvas, for example, you're using now. It's a database that you store your grades and store material for classes and everything. More recently, social networks, Instagram, Facebook, Twitter, X, whatever. environmental and scientific applications, and also medicine and genetics. And we can obviously have some personalized applications based on smart mobile devices. We see now a simplified database system environment. We got users on the top, users and programmers. Then you have a database systems. It's composed of application, programs, and queries. And then you have the database management system software. It's composed of software to process queries and programs, and software to assess stored data. And this stored data can be both it's the stored database definition, that's called metadata, it's data about data, and also the stored database itself. Now we're going to see a database management system. A DBMS is a software system for defining, constructing, and managing database. So with DBMS, you can define a database, you can construct a database, and can also manage a database. It enables users to make queries, to make updates, and to maintain databases. I'm going to show you what a query is in a few slides. And the main components of a database management system are data definitions. It's a database, data about data. It's called metadata. And database manipulation. You can query, you can update, you can report, you have reports, and so forth. And you have also, as a component, security of a database. Very important thing. You have to keep the database secure, and also maintenance of that database. Typical DBMS functionality. You can define, construct, manipulate, and process and sharing data in a database. You can define a particular database in terms of data types, structures, and constraints. You can construct or load the initial database contents on a secondary storage medium. You can manipulate the database maybe with retrievals, querying, generate reports, etc. You can modify that database, maybe insertions and deletions, or maybe updates to the content, and can access the database through web applications. And finally, you can process and sharing by a set of concurrent users and application programs, yet keeping all data valid and consistent. So you can, normally in a database, you have multiple users, and they all can live and see that database, and maybe also can modify that database in sometimes trying to do some modification at the same time. So the system had to deal with that so as not to generate some inconsistency. Application activities against a database. Applications interact with the database by generating queries that assess different parts of data and formulate the result of a request. So I'm going to show you what a query is in a few slides. And also transactions that may read some data and update certain values, or generate new data and store that in the database. So you can process queries and you can process transactions as well. Important, applications must not allow unauthorized users to access data. So you can only have access to a database if you are an authorized user. Otherwise, you won't have access to it. And applications must keep up with changing user requirements against the database. So normally, the requirements change, then the application must be prepared to deal with that. DBMS may additionally provide protection or security measures to prevent unauthorized access. So I told you it's important to prevent unauthorized users to access the system. Also provide active processing to take internal actions on data. Provide presentation and visualization of data, and maintenance of the database and associated programs over the lifetime of database application. So if your database must be kept for many years, you are supposed to be able to maintain the database for the whole life. There are many DBMS, database management systems for relational databases widely used by large companies. Below are the four most known, most used DBMS programs. It's important to note that all these DBMS use SQL as their programming language. So the main four, for example, are MySQL. I'm going to see in this course MySQL. Well, you also have Oracle, you also have SQL Server, and also have PostgreSQL. So SQL stands for Structured Query Language. It's a programming language used to store, query, add, and delete information in a database. This is a universal database language, and it's through it that it becomes possible to query data within databases. To access and query data in a database, it is necessary to use a series of commands. These commands are actually part of a programming language called SQL, as I told you, a structured query language. So you have in the picture here a database, and then you extract part of this database with a query. So for extracting this, you use a language, a programming language called SQL. Then we extract that data, part of data. Then this is a query. For example, you have a table here. You have some products. You have television, computer, phone, PS4, and tablet. And have the sales date, and we have the price. So television, the price is 1,500. The computer is 2,300, and so forth. Then you, using an SQL language, you ask a query. I mean, your query is select from all columns. You're going to see the SQL language in detail in later lessons. So you select every column from the table, sales table, where the amount is greater than 1,000. So your output is going to be, in this case, television, computer, and PS4. So you take all columns from this table here, but only you're gonna only show the columns where the row has amount greater than 1,000. So we're gonna see television, computer, and PS4. The other two, phone and tablet, will not be shown because they are less than 1,000. This is an example of a query. I'm going to use now an example using a mini world called university environment, and some mini world entities in this environment could be students, courses, sections of some courses, departments, and instructors, professors. So you're going to have information about students, course, sections, departments, and instructors. So as I told you in the beginning of this class, relationship is the keyword. So the information have relationship among them. So sections are related to courses, and students take sections. Courses have prerequisite courses. Instructors teach sections. Courses are offered by departments, and students have majors in departments. So the both entities and relationships are typically expressed in a conceptual data model, such as the entity relationship data model. You're going to see this in chapters 3 and 4. So when we build that database, we need to define, for example, like student we'll have 4 columns. For the course, we have 4 columns as well. For the section, we have 5 columns. For the grade report, we have 3 columns. And for the prerequisite, prerequisite, we gotta have 2 columns, for example. And also we define the data type. For example, name, this is gonna be a character data type composed of maximum 30 characters and belongs to the racial student. And the student number column is gonna be 4 characters and it belongs to relation student as well. The class column is an integer on 1 digit and belongs to student as well. Major is it's a data type called major type, and for example, in the below here we see that major type is defined as an enumerated type. So we have all known majors: computer science, math, biology, and so forth. They are enumerated. Then when you are inserting data, you just choose in a list. Course names, a character type with 10 digits, and course number is this format here: XXXS and N. That stands for 4 alphabetic characters followed by 4 numeric digits. So you predefine the format of that data type. So this is just to have an idea, the whole idea of everything. I'm going to show each table separately. So we have the student, course, section, grade report, and prerequisite tables. And then I'm going to see all of them in a separate way. The student table, you have, for example, 4 columns, as I defined before. So I have the column name, column student number, have the column class, and have the column major. So these are our fields. And for example, Smith has a student number 17 and belongs to class 1, I mean year 1, and his major is computer science. And then we have Brown, the student number is 8, the class is 2, year 2, and the major is computer science as well. The table course, we have 4 columns as well, and we have course name, course number, credit hours, and department. First, Introduction to Computer Science, the CS440, 4 credit hours, department Computer Science. Data structures have course number CS3320, have 4 credit hours. The department is also Computer Science. Then have discrete math. That's the course number is Math 2410. Credit hours are 3, and the math in the department is math. And we have database. The course number is CS3380. Credit hours 3 in the department computer science as well. Then we have the section table, and with 5 columns. Section identifier, course number, semester, year, and instructor. You can see here, for example, that you have identifier 85 and 102. Both are Math 2410. Both are fall, but one is year 7 and the other one is year 8, and the instructors are different as well. So they are different sections. Also, it also occurs with CS1310. It's identifier 92 and 109. So both are fall semester. Both have the same instructor, but one is year 7 and the other one is year 8. Then we have a grade report. Then we have the student number, the section identifier, and the grade. So here we can see that it depends from other tables. For example, we have student number 17 that we know 17. We know that is Smith, for example. And we have the section identifier that is 1112, and the grade is B. Then we have Smith again. The section identifier is 109, and the grade is C. And then we have student number 8, that is Brown. The identifier section is 85, and the grade is A, and so forth. Then you have information about grades and students and structures and sections and departments. And finally, we have the prerequisites. For example, course number CS3380 has as a prerequisite CS3320, and then you can construct your information, your table, and then we can make queries to extract the information that you need. I'm going to show you the main actors on the scene. So we have, for example, these roles here: a database administrator, a DBA, a database designers, end users, and software engineers. What is a database administrator, or the DBA, what's known as DBA? DBA is the person who manages database assets, who manage security and manage performance. So it's the people will deal with access controlling, will deal with security, and deals with performance. Then we have database designers. Designers, they will define the structure and the relationships of data. So this table here is related to that table here, and this data here is related to this data here. He or she will define the structure and the relationship of data. Then we have end users, that people that will access and make queries to the database for specific tasks. Have casual users. Casual users access the database occasionally for different information. So now I'm searching for grades, and then tomorrow I can search for schedule, and a week later I can search for some specific student, and so forth. Then you have naive users. Naive users use predefined queries and updates for routine tasks. For example, in a supermarket, a cashier only search for prices for some products, and a manager will search for sales, for example. So they use predefined queries and updates for routine tasks. Then have sophisticated users. They are familiarized with databases and can make complex requirements. And then you have also standalone users. They can maintain personal databases with some easy-to-use software packages. And finally, we have software engineering. They implement applications and queries based on database requirements. Workers behind the scene. We have DBMS designers, we have 2 developers, and we have operators. The DBMS designers will be responsible for build and implement DBMS modules. The 2 developers will create tools for database modeling and design. And the operators will maintain the hardware and software environment of the database system. The main characteristics of the DBMS approach. We have self-describing natures. Database systems store both data and its description. Description is metadata. That metadata, as I told you, is data about data. So they have a self-describing nature. Program data independence. I mean, changes to data structure don't affect application programs. So if you have to make changes to some data structure, this will not affect application programs. So there is an independence between data and program. Multiple views of data allow various users to access data from different perspectives. So some users can have a view over sales, and some other user will need a view over timelines, and other can have a view over profit, and so forth. And multi-user transaction processing ensures that multiple users can update data concurrently without issues. I mean, 2 users are trying to update that database at the same time. So the system have to deal with that, so that there will not be any issue with that. So one trying to do what 2 users are trying to modify the data, so the system will make it like a queue, a line, and then this one will be the first, and the second one will be the second, and then the modifications that they will try to perform will be managed by the system in order that there will be no issues. Controlling redundancy minimizes data duplication and inconsistency. I mean, if you are using Excel spreadsheet, for example, and let's suppose that two users manipulate that spreadsheet. In an Excel spreadsheet, you don't have a database. You have only a sheet, a spreadsheet. So there is a possibility that two different users, when inserting data, can write in different ways. For example, you have information about universities and, for example, graduate programs, and then someone is storing a math course, and the university is SIMO, and then he puts math, the uh, algebra, linear algebra is offered by SIMO University, and then when in the column university he puts SIMO, and the other user are inserting another course, then they puts biology, and then some specific class in the column university. Instead of putting SIMO, he puts Southwest Missouri State University. Then if someone makes a filter by university, the two entries will be different because one is SIMO, the other one is Southeast Missouri State University, although both are related to the same university. So this is inconsistency, redundancy, because there are two information written in a different way. So they for the filter they will represent different things, but they basically they are the same thing. So when you use a database management system, it's easier to avoid this because you have some ways to control this, maybe creating lists, and you can consult the correct name of the university, so it's not two different users put different names for them for that. So when you use a DBMS, you reduce the risk of inconsistency. Also, security and access control. So prevents unauthorized users and ensures data integrity. What is data integrity? Integrity, when we talk about security, is when you ensure that the information is not modified between the origin and the destiny. So you guarantee that that data will not be modified by an unauthorized person. Also, we have efficient query processing. Uses indexing, query optimization, and caching. So using this, you can make the query more efficient. And also backup and recovery. I mean, also ensures data integrity in case of failures. You are using your database and maybe there is some crash, and then if you have backup, you can recover everything without loss. Additional implications of using database approach. First, we have potential for enforcing standards. This is very crucial for the success of database applications in large organizations. Standards refer to data item names, display formats, screens, report structures, metadata, web page layouts, etc. So you define some standards that are going to be used, and then this is crucial for the success of the database application. And also reduced application development time. Incremental time to add each new application is reduced when you use a DBMS approach. Another implications, flexibility to change data structure. Data structure may evolve as new requirements are defined. And every time you need to modify the structure, if you're using a database management system, this is going to be easier. Availability of current information. Whenever you are authorized user, whenever you you need to access the data this is going to be available for you. So extremely important for online transactions. Systems like shopping, airline, hotel, car reservations. For example, you are two users are at the same time searching for a room in a hotel, and there is only one room available. The system must to guarantee that they will not be able to book the same room. It's the same occurs with airline tickets. There is only one left room seat in the airplane. So if two are searching for the same time, the system have to create some rules as to who is the person who will get that seat. So sorry, they'll not be able to reserve the same seat in that plane. So the database system must deal with that so as to avoid this concurrent information. The same occurs with shopping, for example, car reservation, and so forth. And economies of scale. A wasteful overlap of resources and personnel can be avoided by consolidating data and application across departments. So when you use a database system, you reduce the possibility of waste. Now I'm going to pose some historical context and evaluation of databases. We divide this in 4 steps. The early database systems were basically hierarchical network systems, and they had limited flexibility. Then we get relational database. It makes separation of data structure from storage, and they make query language more flexible. Then we have object-oriented databases. They have support for complex objects, integration with programming languages. And now we have big data and NoSQL, evolution for managing large databases, social media, and cloud storage. So talking about each of them separately in a more detailed way. Early database applications. We have the past hierarchical and network models were introduced in the mid-60s and dominated during the 70s. A bulk of worldwide database processing still occurs using these models, particularly in the hierarchical model using IBM's IMS system. Then in the 70s, we had relational database systems. Relational model was originally introduced in 1970 and was heavily researched and experimented with within IBM research and several universities. Relational database management system products emerged in the early 80s. Then we have object-oriented and emerging applications. Object-oriented database management systems, called OODBMS, were introduced in the late 80s and early 90s to cater to the need of complex data processing in a computer-aided design and other applications. The use has not taken off much. Many relational database management systems have incorporated object database concepts, leading to a new category called object relational database management systems. Extended relational systems and further capabilities, for example, multimedia data, text, XML, and other data types as well. Another historical development of database technology is data on the web and e-commerce applications. The web contains data in HTML with links among pages. This has given rise to a new set of applications, and e-commerce is using new standards like XML. We're going to see this in chapter 13. Scripty programming language such as PHP and JavaScript allow generation of dynamic web pages that are partially generated from a database. We're going to see this in chapter 11. And also allow database updates through web pages. Now, let me go ahead and show extending database capabilities. New functionality is being added to DBMS in the following areas: specific applications like physics, chemistry, biology, genetics, earth and atmospheric sciences and astronomy, XML, image storage and management, audio and video data management, data warehousing and data mining, a very major area for future development using new technologies. We're going to see this in chapters 2089. And spatial data management and location-based services, and also time series and historical data management. The above gives rise to new research and development in incorporating new data types, complex data structures, new operations and storage in indexing schemes and database systems. Background since the advent of the 21st century. First decade of the 21st century has seen tremendous growth in user-generated data and automatically collected data from applications and search engines. Social media platforms such as Facebook and Twitter are generating millions of transactions a day, and businesses are interested to tap into this data to understand the users. As I told you, they will always try to understand you in order to know what you like and keeping you connected and offering you product that you might buy. Cloud storage and backup is making a limited amount of storage available to users and applications. Now you can store everything in the cloud, so you can store millions and millions of bytes. Emergence of big data technologies and NoSQL databases. New data storage, management, and analysis technology was necessary to deal with the old slough of data in petabytes a day, 10 raised to the 15th power bytes, or 1,000 terabytes in some applications. This started being commonly called as big data. Hadoop, which originated from Yahoo, and MapReduce programming approach to distributed data processing, which originated from Google, as well as the Google file system, have given rise to big data technologies. Chapter 25, we're going to see this. Further enhancements are taking place in the form of Spark-based technology. NoSQL, not only SQL, where SQL is the facto standard language for relational database system. We saw this in this class. Has been designed for rapid search and retrieval for documents, processing of huge graphs occurring on social networks, and other forms of unstructured data with flexible models of transactional processing. Chapter 24, we will deal with that. The final topic in this class today is going to be when not to use a DBMS. The main costs of using a DBMS are high initial investment and possible need for additional hardware, and overhead for providing generality, security, concurrency control, recovery, and integrity functions. So when a DBMS may be necessary, if a database may be unnecessary, if the database and applications are simple, well-defined, and not expected to change, and if access to data by multiple users is not required. For example, if you are the only user, the only person that will insert and delete data, update data from that database, you can use, and the data are not supposed to change that much. You can simply use a spreadsheet in Excel. When a DBMS may be infeasible in embedded systems where a general purpose DBMS may not fit in available storage. So you have limited capacity for storage, so it may not be feasible to use a database management system. No DBMS may suffice, may not be enough. If there are stringent real-time requirements that may not be met because of a DBMS overhead, for example, telephone switching systems. If the database system is not able to handle the complexity of data because of modeling limitations, for example, with complex genome and protein databases. And if the database users need special operations not supported by the DBMS, for example, geographic information systems and location-based servers. As a summary of the lesson today, we learned that database is a collection of related data. A DBMS, is database management system, enables management and manipulation of databases. The database approach offers numerous advantages over traditional file processing, including, among others, better data integrity, access control, and flexibility. And understanding the database approach helps design efficient, scalable systems for diverse applications. Finally, this is our assignment for this week. I'd like to know you, and I'd like that you know each other. So introduce yourself. You gotta say your name, your full name, and name you prefer your fellow classmates to call you, your current major, have you done internship, TS, CY club, interacted with career services, any software that you are particularly good at, any semester project area that you would like to do, any experience in working with clients in computer science, what area of computing you plan to specialize in, for example, web development, machine learning, for example. What are your expectations in taking this course? Your programming experience, including work, programming languages you are familiar with, or have you used the past, or software project you have worked in the past. What do you expect to use? How do you expect to use your major? What kind of job you intend or hope to work after graduating from CMO? Other things such as your interests, full fun or interesting experiences you'd like to share with your fellow classmates. Have you ever used any database management system before? Have you ever worked with a database before? If yes, in what situation? Please write your answers in the discussion section of Canvas and also record a short video. This is all for today, guys. See you next class. Thank you so much.